Part 1. Introduction. The human desire to create immortal structures since the beginning of human civilization. People have always carried a remarkable ambition. The desire to build structure that can survive far beyond their own lifetime. Throughout history, humans have searched for ways to create buildings, monuments, temples, palaces, an entire city that could withstand the passage of time and preserve their achievement for future generations. The ancient structures that still exist today are powerful evidence of this timeless dream. They represent humanity's determination to leave a permanent mark on Earth and create something that continues to tell stories long after the original builders are gone. The extraordinary buildings are not simply places made of stone, brick, or other material. They are symbols of human intelligence, creativity, and the desire to achieve something that can last forever. Over the thousands of years, countless civilizations have risen and disappeared, yet some of their greatest architectural achievements remain standing. These structures have survived war, natural disasters, climate changes, and the transformation of entire society. Their survival is a testament to the incredible skill and knowledge of ancient builders who created design far ahead of their time. Many ancient buildings were constructed without this advanced technology available today, yet they continue to impress modern engineers and architects. The builders of the past understood important principles of structure, material, and environmental adaptation. They carefully selected durable material, developed innovative construction methods, and created design capable of resisting the challenges of nature. From massive stone monuments and ancient temples to powerful fortresses and historic cities. These long-lasting structures reveal the extraordinary ability of human civilization. They show that architecture is not only about creating functional spaces, but also about expressing ideas, preserving culture, and connecting different generations through time. In the modern era, advances in science, engineering, and material technology have opened new possibilities for creating even more durable buildings. Architects and researchers are now exploring stronger construction material, self-healing concrete, advanced protective coating, and sustainable design that could allow future structures to survive for hundreds of even thousands of years. This progress has led to a fascinating question. Can humans create buildings today that still exist thousands of years in the future? Modern society faces new challenges, including climate change, extreme weather conditions, and increasing urbanization. Future buildings must not only be strong but also adaptable, environmentally responsible, capable of maintaining the function over extremely long periods. The goal is no longer simply to build taller or larger structures, but to create architecture that can truly stand the test of time. The most durable buildings in history are more than just architectural achievement. They are like time machines that preserve the memory, knowledge, and experience of people who create them. By studying these structures, we gain a deeper understanding of past civilization and the value they wanted to pass on to future generations. Every ancient monument carries a message from the past. The stone wall, and foundation of the building, silently tell stories about human ambition, creativity, struggle, and achievement. They remind us that while individuals may disappear, the idea and creation of humanity can continue to live on, and technology continue to evolve. The dream of creating truly immortal buildings remain alive. Future architects may one day develop structure capable of lasting for thousands of years, becoming landmarks that represent the achievement of modern civilization. Ultimately, the desire to build structure that outlast time reflects one of the humanity's greatest ambition, the search for permanence in a constantly changing world. The buildings that survive for thousands of years are not only monuments of architecture, they are lasting symbols of human imagination, determination, and the endless pursuit of greatness. Part 2. The Great Pyramid of Giza, the 4,500-year-old wonder that still stands when discussing the world's most durable structure that have survived for thousands of years. It is impossible to ignore the Great Pyramid of Giza as one of the 7 wonders of the ancient world and the only one still largely preserved today. The pyramids represent one of the greatest achievements in human history. It is not only an extraordinary architectural masterpiece, but also a powerful symbol of humanity's ability to create structures that can come over the passes of time. Located on the Giza Plateau near modern-day Cairo, Egypt, and Great Pyramid were constructed approximately 4,500 years ago during the Old Kingdom period of ancient Egypt. It was built as monumental tomb for Pharaoh Khufu, also known as Cheops, and were designed to demonstrate a power, knowledge, and technological ability of ancient Egyptian civilization. At the time of its completion, the Great Pyramid was the tallest man-made structure on Earth, reaching an original height of approximately 146 meters for thousands of years. It remains the world's tallest building, a record that highlights the incredible scale and ambition of its construction. The pyramid was created using millions of massive stone blocks, with each block weighing several tons. The transportation, placement, and alignment of the enormous stone remain among the greatest engineering mysteries in history. What makes the achievement even more remarkable is that the ancient Egyptians built this massive structure without modern machinery, crane, or advanced construction equipment. Instead, they rely on careful planning, mathematical knowledge, engineering skill, and organized human labor. The precision of the pyramid's design continues to amaze modern experts. The structure was carefully aligned with the cardinal direction, and its geometric accuracy demonstrates an impressive understanding of measurement and architecture. One of the main reasons the Great Pyramid has survived for thousands of years is its exceptionally stable design. The pyramid shape itself provides incredible structural strength. Unlike vertical walls that can experience significant pressure and instability over time, the wide base gradually narrow and safe, allow the weight of the stone to distribute evenly to a ground. Another important factor is the huge massive stone block. The limestone and granite used in the construction are extremely durable material capable of resisting an environmental damage for thousands of years. These heavy stones create a solid structure that could withstand earthquake, erosion, and the harsh conditions of the Egyptian desert. The foundation of Great Pyramid also played a crucial role in survival. Built on the carefully selected area of solid rock, the pyramids rest on a stable base to prevent major shifting or collapse. Ancient builders understood the importance of choosing the right location and preparing the ground before construction began. The desert environment surrounding the pyramid also contributed to its preservation, although extreme temperature, wind and sand erosion had affected the outer surface over time. The right climate helped protect the inner structure from the moisture-related damage. Unlike buildings in weathering environment, the pyramids were able to avoid many forms of decay caused by water. Over thousands of years, the Great Pyramid has experienced some changes. The original submerged outer limestone covering has mostly disappeared, leaving the rough inner stone structure visible today. However, the core of the pyramid remained remarkably intact, demonstrating the strength of the original design. The survival of the Great Pyramid of the Giza proves that intelligent architecture can overcome the power of time. It's not a simple movement made of stone. It is a message from an ancient civilization showing the importance of knowledge, planning, and innovation. Today, millions of people visit the Great Pyramid every year, fascinating by mystery and incredible endurance. It continues to inspire architects, engineers, and historians around the world who study how such ancient structure could remain standing after thousands of years. The Great Pyramid of Giza is more than an ancient wonder. It is a timeless symbol of human ambition and creativity, a reminder that when intelligence and determination together, humans can create an achievement that truly transcends generations. Part 3. The Pantheon, Rome nearly 2,000 years old concrete masterpiece located in the heart of Rome, Italy. The Pantheon is one of the best preserved ancient buildings in the world. Standing for nearly 2,000 years, this extraordinary structure represents incredible engineering knowledge of the Roman Empire and remains a powerful example of how advanced ancient construction technique could create buildings capable of surviving through centuries of change. The Pantheon was originally during the Roman Empire, with the current structure completed around 128 AD under the reign of Emperor Hadrian. Although it was created almost 2,000 years ago, the building remains remarkably intact today. Unlike many ancient monuments that have been damaged by war, natural disaster, or time, the Pantheon continued to stand as a living symbol of Roman architectural genius. The most famous feature of the Pantheon is the enormous concrete dome, which were considered one of the greatest engineering achievements of the ancient world. For centuries, the dome held the record as the largest unreinforced concrete dome ever built. Even modern engineers continue to study the design because its impressive strength, balance, and durability. The secret behind the Pantheon's incredible longevity lies largely in the unique property of ancient Roman concrete. Unlike many modern concrete mixtures that can weaken when exposed to environmental conditions, Roman concrete has demonstrated remarkable durability over the thousands of years. The Romans created the concrete using the special combination of natural materials, including volcanic ash, limestone, seawater, and other minerals. This mixture produced a strong building material that could withstand extreme conditions and maintain its structural integrity for centuries. One of the most fascinating aspects of Roman concrete is its ability to become stronger over time. Scientists have discovered that certain chemical reactions within the material allow it to repair small cracks under specific conditions. When water enters a tiny crack in the concrete, mineral can form and gradually fill the gap, helping prevent further damage. This self-healing ability is one of the reasons why structures like a Pantheon have survived for so long. The combination of durable material, intelligent design, and careful construction allowed Roman engineers to create buildings that could resist the effects of erosion and environmental pressure. The design of the Pantheon dome also demonstrates the extraordinary engineering skill. The dome gradually becomes lighter to the top use of different material and construction techniques. The lower section contained heavier material to provide strength, while lighter material were used higher up to reduce pressure on the structure. At the center of the dome is the famous ocular, a circular opening that allows natural light to enter the building. This feature not only creates a dramatic interior atmosphere but also reduces the weight of threat of the dome upper section. The interior space of the Pantheon remains one of the most impressive architectural experiences in the world. The perfect balance between the circular design, massive dome, and natural lighting creates a sense of harmony that has influenced countless architects throughout history. Over the century, the Pantheon has served many purposes. Originally built a temple dedicated to Rome and gods, it was later converted into a Christian church and became a place of historical and cultural importance. Its ability to adapt to different eras had helped preserve and one of the Rome's greatest landmarks. The influence of the Pantheon can be seen in many later buildings around the world. Architects have studied its dome, proportion, and structural principles for centuries, from government buildings to museums and churches. Many modern structures have been inspired by the idea first demonstrated by Roman engineers. Today, the Pantheon stands are more than just an ancient monument. It is proof that intelligent design and high-quality material can overcome the power of time. Its nearly 2,000 years old dome continues to remind the world the extraordinary achievement of ancient engineering. The Pantheon is a timeless masterpiece, a building that connects the past with the present, that demonstrates that great architecture is not only created to the services on our era, but also to inspire generations far into the future. Past 4. The Stonehenge India architecture that had endured through space and time. India is home of one of the most extraordinary ancient structures in the world, many of which were created with a powerful ambition to survive for thousands of years. The remarkable temple were not built not only a place of worship but also in symbol of human creativity, devotion, and the desire to create something that could outlast generations. Among the greatest examples of India's timeless architecture is Kailasa Temple, Located in the Ellora cave of Maharashtra, the incredible monument is considered one of the most impressive achievements of ancient rock cut architecture and continues to amaze historians, architects, and visitors from around the world. What makes the Kailasa temple truly unique is the way it's created. Unlike traditional buildings that's constructed by assembling separate stone, the entire temple was carved direct from a single massive block of volcanic rock. Instead of adding material together to form a structure, ancient craftsmen removed enormous amounts of stone from the mountain itself, gradually revealing the temple hidden within. These construction methods require extraordinary skill, patience, and vision. Ancient artisans worked from the top of the rock downwards, carefully carving away thousands of stone to create complex architectural complex. The process took many years, were carried out by generational skilled workers who passed their knowledge and techniques from the one group to the next. The result and breathtaking monument feature incredible detailed stone carving, massive pillar, elaborate sculpture, and enormous corridor carved entirely from solid rock. Every surface of the temple reflects the craftsmanship and artistic ability of the people who created. One of the most impressive aspects of the Kailasa temple is the precision of its design. Despite being carved from a single rock formation, the temple includes complex architectural elements that resemble traditionally constructed buildings. It contains multiple levels, carefully designed spaces, and detailed decoration that demonstrate a deep understanding of engineering and artistic principles. The temple stone columns are especially remarkable. Each pillar was carefully shaped and decorated with intricate pattern and aesthetic detail. The walls and surfaces are covered with detailed relief carving depicting story, religious scenes, and symbolic figures. These artworks were not simply decorative, they represent spiritual belief and cultural value of ancient Indian civilization. Because the Kailasa temple was carved from a piece of rock, it possesses exceptional durability. Unlike the building made from separate blocks that can weaken over time due to cracks between material, a structure carved directly from natural stone has greater structural stability. The surrounding rock provides natural strength and protection against many environmental challenges. Over centuries, the temple has survived changing weather conditions, natural erosion, and the passage of time. Although some details have been affected by aging, the main structure remains remarkably preserved, proving the effectiveness of ancient construction technique. The Kailasa temple also represents an important connection between architecture and faith. For the people who created it, the temple was not merely a building but a sacred space designed to honor spiritual belief. The enormous efforts required to carve such a monument demonstrate the deep devotion and determination of ancient community. Beyond its religious importance, the temple provides valuable insight into the knowledge and ability of ancient engineers and artists. It shows that sustainable or long-lasting architecture does not always require modern material or advanced technology. Sometimes, the most powerful construction method is to work with the natural strength of the environment itself. The creation of the colossal temple is the reminder that human creativity can transform natural landscape into extraordinary work of art. By understanding the poverty of stone and using careful planning, ancient builders created a monument capable of surviving for more than 1,000 years. Today, the Kailasa Temple stands one of the greatest examples of architecture that has successfully merged nature, engineering, and spirituality. It represents the timeless lesson. The most enduring structures are not always those made with the newest material, but those created with knowledge, patience, and respect for the strength of nature. The temple continues to inspire modern architects and researchers who study how ancient civilizations achieved such remarkable durability. It remains a powerful symbol of human imagination and a masterpiece that proves great architecture can truly transcend. Part 5. Hathor, the ancient stone city that lived within the mountain, located in modern-day Jordan. The ancient city of Hathor is one of the most extraordinary examples of architecture that have survived through thousands of years. Unlike traditional cities built with separated structure placed on the ground, Hathor represents a completely different approach to construction. A city created directly from the mountains themselves. Built more than 2,000 years ago by the Nabatean civilization, Petra is famous for its magnificent building carved into the natural sandstone cliff. This remarkable city demonstrates how ancient people were able to combine creativity, engineering knowledge, and a deep understanding of nature to create a settlement that could endure the challenges of time. The Nabateans were skilled engineers, traders, and architects who developed Petra as a major center of commerce and culture. Located along important trade routes connecting Arabia, Egypt, the Mediterranean, and other regions, Petra became a wealthy and influential city. Its success was not only based on this location, but also on remarkable architecture and water management system created by inhabitants. The most famous feature of Petra is the way building carved directly into the rock. Instead of transporting large amounts of construction material or building structure from separate stone, the Nabateans transformed the mountain into living architecture. They carefully removed layers of sandstone to reveal temple, tomb, hall, and monumental entrances hidden with the cliff. The most iconic structure in Petra is El Kaitna, also known as the Treasury. This magnificent facade was carved into the face of a sandstone mountain and featured detailed column sculpture and artistic decoration. Although it appeared like a massive building constructed from stone block, it is actually part of the mountain itself. The technique used by the Nabateans provided several advantages for long-term durability. Since the structures were carved from natural rock, there were fewer weaknesses by joint between separate materials. The surrounding stone offered natural protection and helped the building remain stable despite centuries of environmental changes. Petra's survival is also closely connected to the Nabatean and understanding of the harsh desert environment. The region experienced extreme temperature, limited rainfall, and difficult living conditions. To survive, the Nabateans developed advanced water collection and distribution system, including channel, reservoirs, and underground structure that allow them to control and store precious water resources. This knowledge the environment helped Petra become not only a beautiful city but also a highly functional one. The inhabitants understood how to work with nature rather than against it. The ability to adapt to the desert landscape was a key reason why the city flourished for centuries. Over time, Petra faced many challenges. The city experienced earthquakes, changing trade routes, political transformation, and the decline of the Nabatean civilization. Despite the difficulty, many of its stone structures remain standing. The natural strength of the sand-of-time intelligence of the original design allowed Petra to survive through the countless generations. The desert's environment also played a role in preserving the city. Although wind, rain, and erosion have gradually affected some areas, the dry climate helps protect many of the structures from rapid deterioration. The combination of natural material and careful engineering allowed Petra to remain one of the world's greatest archaeological treasures. Today, Petra is recognized as one of the most important ancient architectural achievements on Earth. It attracts visitors from around the world who come experience its breathtaking landscape and explore remarkable relationship between human creativity and natural stone. More than just an ancient city, Petra represents a powerful lesson in sustainable architecture. It shows that some of the most durable structures are created not by overpowering nature, but by understanding and working with it. The Nabateans did not simply build on the landscape, they became part of it. Petra stands as a timeless symbol of human imagination, resilience, and adaptation carved into the mountain and preserved through centuries of change. This incredible stone city proves that architecture can become one with nature and truly survive beyond the limits of time. Part 6. The secrets behind the building have survived for thousands of years. The buildings that have survived for thousands of years are not simply the result of strong material. The incredible durability comes from a combination of several important factors, including carefully selected material, intelligent design, and construction methods that work in harmony with nature. Ancient civilizations did not have modern technology, advanced machinery, or computer simulation. Yet they were able to create structures that continue to stand today. The achievement demonstrates that long-lasting architecture depends not only on innovation but also on a deep understanding of material environment and structural principles. 1. The use of durable and sustainable material. One of the most important reasons ancient buildings have survived for centuries is the use of extremely durable material. Ancient builders carefully selected material that could resist weather, pressure, and environmental changes over the long periods of time. Natural stones was one of the most common materials used in ancient construction. Materials such as granite, limestone, and sandstone were chosen because of their strength and ability to withstand erosion. Massive stone structures like a pyramid, temple, and carved city have remained stable because the stone itself provides excellent resistance against time and natural forces. Burnt bricks were another important material used by many ancient civilizations. Through controlled heating processes, building creates stronger bricks that could resist moisture and temperature changes. Many ancient cities around the world were constructed with carefully made bricks that have survived for thousands of years. Ancient concrete was another remarkable innovation, especially in Roman architecture. Roman builders developed unique mixtures contained in volcanic ash, lime, water, and other natural materials. These concretes became incredibly strong and, in some cases, even improved over time. Structures such as a Pantheon demonstrates how ancient material could achieve extraordinary durability. In addition to stone and concrete, some civilizations also used medical and protective techniques to increase the lifespan of the structure. Modern buildings continue to learn from these principles by developing stronger, more sustainable materials that resist corrosion and environmental damage. 2. Design that works with nature. Another important secret behind long-lasting buildings is their ability to adapt to the natural environment. Ancient architects understood that successful structure must not fight against nature but instead work together with it. Before construction began, many ancient builders carefully studied environmental conditions such as wind direction, sunlight pattern, soil quality, and climate. These observations help them create buildings that can remain stable and comfortable for generations. For example, the orientation of the building could influence how much sunlight it receives and how effectively it could maintain temperature. Many ancient structures were positioned according to the movement of the sun, allowing natural light to enter while reducing excess of heat. Geological knowledge was also essential. Choosing the correct location and understanding strength of the ground helped prevent structural failure. Many ancient monuments were built on stable foundation because the creator understood that strong building began with strong ground. Climate adaptation was another important factor. In desert regions, builders created structures that could handle extreme heat and dryness. In areas with heavy rainfall, they developed drainage systems and designed protected buildings from water damage. These examples show that durability is not only about creating a powerful structure. A building must also be designed to exist naturally with the surrounding. 3. Simple but strong structural principle. One of the most impressive features of ancient architecture is the simplicity. Many structures that have survived thousands of years do not rely on complicated technology but instead use intelligent and efficient design. Thick walls accommodate future invention building. Large stone walls provide excellent stability and protect interior from temperature changes, strong wind, and external damage. Deep foundations are another important element. Ancient builders understood that a stable foundation prevents movement and protects structure from shifting over time. By creating strong bases, they ensure that massive buildings could remain standing for centuries. Balance shape also plays a major role in structural strength. The pyramid shape, for example, distributes weight naturally to the walls, creating the exceptional to stable ability dome arches and other curved structures used by ancient engineers also allow heavy load to be distributed efficiently. Another key principle was proper weight distribution. Instead of placing pressure unneeded only a certain area, ancient architects designed structures where forces were balanced throughout the entire building. This reduced stress and helped prevent collapse. Lesson from ancient architecture: the survival of building for thousands of years is not the result of the single secret. It is the result of combining strong material, intelligent design, and a deep understanding of nature. Ancient architects proved that durability comes from harmony between human creativity and the environment. The buildings survived because they were not only strong but also carefully adapted to the world around them. Today, modern engineers continue to study the ancient masterpieces to discover new ways of creating sustainable and long-lasting structure. The lesson from the past reminded of the greatest buildings that not necessarily those are the tallest or most technological advanced, but those designed with wisdom, balance, and respect for time itself. The secrets of ancient architecture show that when knowledge and creativity come together, humans can create structure capable of standing for thousands of years and carrying the story of civilization into the future. Part 7. Future building that could last for thousands of years. Today, scientists, engineers, and architects are exploring new technology and advanced material with the goal of creating buildings that can survive for extremely long periods of time. While many modern structures are designed to last for several decades or centuries, future architecture may aim much higher, creating buildings that can remain functional for thousands of years. The idea of creating nearly permanent structure is no longer just a dream. Advanced material science, artificial intelligence, and sustainable engineering are opening new possibilities for the building that can resist environmental damage, repair themselves, and adapt to changing conditions. Unlike ancient structures that survive through careful design and durable natural material, future buildings will combine traditional engineering principles with advanced technology. The goal will not only be to create stronger structures but also intelligent buildings that can actively protect and maintain themselves over time. 1. Self-healing concrete, one of the most promising technology for future construction and self-healing concrete. Traditional concrete can develop small cracks over time due to pressure, temperature changes, earthquake, and environmental exposure. If these cracks are not repaired, water can enter and gradually weaken the structure. Self-healing concrete designed to solve this problem. Scientists are developing special material that can automatically repair small cracks without human intervention. Some type of self-healing concrete use bacteria, special chemical, or microscopic capture that release repair material when damage occurs. This technology could significantly extend the lifespan of buildings, bridges, and other infrastructure. Instead of slowly deteriorating and requiring frequent repair, future structures could maintain their strength and durability for much longer periods. 2. Ultra-strong nanomaterial. Nanotechnology is also expected to transform the future of architecture. Engineers are researching material at the micro-phase level to create substances that are lighter, stronger, and more resistant to traditional construction material. Nanomaterial could allow buildings to withstand extreme forces such as earthquake, powerful storm, and temperature changes. These materials may provide greater strength while reducing the overall weight of structure, making it possible to create more efficient and durable design. Future skyscraper, bridges, and large buildings may rely on advanced materials that combine incredible strength with flexibility. This could help structures survive environmental challenges that could damage conventional buildings. 3. Smart glasses and adapted building material. Another important development in tissue intelligent material, including smart glass. Unlike traditional windows, smart glass can adjust the property according to environmental conditions. For example, smart glass could automatically control the amount of sunlight entering a building, helping maintain comfortable indoor temperature while reducing energy consumption. This technology could allow buildings to adapt naturally to changes in weather and climate. Future buildings may also use adaptive materials that respond to their surroundings. These materials could change their property based on temperature, humidity, or structural pressure, helping protect the building and improve efficiency. 4. Corrosion-resistant metal. Metal is widely used in modern construction, but corrosion remains one of the biggest threats to long-term durability. Explosion to water, salt, and pollution can gradually weaken metal structure. Future engineering may rely on advanced corrosion-resistant metal and protective coating and prevent damage for much longer periods. The material will be especially important for buildings located in coastal areas or environments with harsh weather conditions. By reducing corrosion, engineering can create structures that require less maintenance and remain safe for many generations. 5. Intelligent structure monitoring system. Future buildings may also become increasingly intelligent to advanced monitoring system. Instead of waiting for engineers to discover problems during inspection, buildings could continuously monitor their own condition. Thousands of smart sensors could be installed throughout the structure to measure movement, pressure, temperature, and material performance. Artificial intelligence systems could analyze this information, detect early signs of damage. For example, a future building could automatically identify a small crack, warn engineers, and recommend repair before the problem becomes serious. This type of technology could dramatically improve safety and extend the lifespan of structure. Buildings that adapt and maintain themselves. The building of the future may not simply survive for thousands of years. They may actively adapt to the environment. A truly advanced structure could automatically adjust the temperature, optimize energy use, recycle resources, and repair minor damage. Instead of being passive objects, future buildings could become living systems that respond intelligently to changing conditions. For example, a building might use renewable energy resources, reuse water, adjust lighting based on natural conditions, and modify its internal environment to improve comfort and efficiency. towards architecture beyond time, humanity has always searched for a way to create structure that can overcome the power of time. Ancient monuments such as pyramids, temples, and stone cities prove that intelligent design and durable material could create buildings that survive for thousands of years. The future will take this idea even further. With self-healing material, smart technology, advanced sensors, and sustainable design, future buildings may achieve levels of durability that were once impossible. The goal of future architecture is not only to create beautiful buildings, but also create structures that can protect themselves, adapt to nature, and to continue serving humanity for generations. Perhaps one day, humans will create a new generation of architecture, buildings that are not merely designed to last a lifetime, but designed to become timeless monuments of human innovation. Part 8. The challenges of building structure that can last thousands of years. Although technology continues to expand rapidly, creating a building can survive for thousands of years remains one of the greatest challenges in modern architecture and engineering. Designing a structure that can endure centuries requires much more than strong material and advanced construction techniques. Engineers must consider environmental changes, economic limitations, and evolving needs of future society. A building that lasts for thousands of years must not only be physically durable, but also remain meaningful and useful across many generations. This creates a unique challenge. How can humans design structures that are all strong enough to survive time while still adapting to a constantly changing world? 1. The impact of climate change. One of the biggest challenges facing future long-lasting buildings is climate change. The environment around the world is changing faster than ever before, creating new risks for architectural structure. Rising temperature can affect a construction material by causing expansion, contraction, and gradual weakening. Extreme heat can damage surfaces, increasing energy demand, and accelerate the aging process material. Sea level rise is another major concern, especially for buildings located in coastal areas. Many of the world's largest city important structures are built near ocean and river. As water level increase, future buildings may face greater risks from flooding, saltwater corrosion, and coastal erosion. Extreme weather events are also becoming more frequent and intense. Stronger storms, hurricanes, heavy rainfall, and powerful wind can place enormous pressure on buildings. A structure designed to last thousands of years must be capable of surviving environmental conditions that may be very different from those experienced today. To address these challenges, future architects will need to create buildings that are not only strong but also adaptable. Structure may require advanced material, flexible design, and intelligent system can respond to changing climate conditions. 2. The high cost of construction and maintenance. Another major challenge is enormous costs involved in creating ultra-durable structure. A building designed to last thousands of years will require the highest quality material, advanced technology, and careful construction methods. Future long-lasting building may depend on expensive innovations such as self-healing concrete, advanced nanomaterial, smart monitoring system, and environmental friendly technology. While these solutions can greatly improve durability, they also increase construction costs. Expense does not end up after the building completed. A structure designed to survive for thousands of years will require continuous maintenance monitoring. Even the strongest materials will eventually need inspection, repair, and improvement. Long-term maintenance systems must be carefully planned from beginning. Engineering must consider how future generations will access, repair, and upgrade the building. A structure that survives physically but becomes too different because of expensive maintenance may not truly achieve purpose. Therefore, creating buildings that can last thousands of years requires not only technological innovation but also long-term financial planning and commitment. 3. Changes in society and human need. Perhaps one of the most difficult challenges is not related to material or engineering, but to society itself. A building may be strong enough to survive thousands of years, but will it still have value in the future? Human lifestyle, culture, technology, and needs constantly change. A structure that is useful today may become unnecessary or outdated hundreds of years from now. For example, many ancient monuments survive because they had cultural releases or historical importance. Their value was not only practical but also symbolic. They represent the belief, achievement, and identity of civilization that created them. Future buildings will need to have similar long-term significance. They must be designed not only a physical structure, but also in meaningful spaces that future generations will want to preserve. Adaptability will become a key factor in the future architecture. Buildings may need flexible design that allow them to change function over time. A structure that can be transformed and reused is more likely to survive through different eras. Creating architecture beyond generation, building a structure that can exist for thousands of years is one of humanity's greatest architectural ambitions. However, achieving this goal requires overcoming challenges far beyond simple construction. Climate change, financial limitation, and social transformation all create obstacles that future architects must solve. A truly timeless building must be strong enough to resist nature, affordable enough to maintain, and valuable enough to remain meaningful for generations. The greater building for the future will not simply be those that survive the longest. They will be structures that continue to serve, inspire, and connect people across centuries. Creating architecture that lasts thousands of years is ultimately about more than defeating time. It is about designing a legacy, a gift from one generation to another, carry human knowledge, creativity, and imagination into the distant future. Part 9. Conclusion. The immortal mass of humanity building that can survive for thousands of years, among the greatest achievements of human civilization. They are not simply architectural structures made of stone, concrete, or other material. They are lasting records of human intelligence, creativity, and ambition. The extraordinary creation can be seen as book written in stone, preserving the story, knowledge, and dream of civilization that existed long before our time. Throughout history, humans have always searched for ways to leave a permanent mark on the world. While individual light or temporality, the structure people create can continue to exist for centuries, for even millennia. The ancient monuments that remain today are powerful reminders that human imagination has the ability to overcome limits of time. The great pyramids of Giza, the Pantheon in Rome, the Stone Temple of India, and the ancient city Petra all demonstrate different approaches to creating architecture that can endure. Each of masterpieces reflect the unique knowledge, culture, and value of the civilization that built it. The Great Pyramids of Giza show the incredible precision and engineering ability of ancient Egypt. Built thousands of years ago with massive stone blocks, it continues to stand as a symbol of human determination and organization skill. The Pantheon demonstrates the remarkable understanding of Roman engineering, especially through its revolution ever conquest and its perfectly designed dome. Nearly 2,000 years later, it remains one of the greatest examples of architectural balance and structural innovation. The Stone Temple of India reveals another dimension of long-lasting architecture. By carving entire structure directly from mountain, ancient craftsmen created monuments that became one of the natural landscape. Their works prove that durability can come from understanding and respecting the strength of nature. The ancient city of Petra represents humanity's ability to transform the environment into extraordinary living spaces. Instead of building against the mountain, the Nabateans worked with the rock itself, creating the city that has survived countless generations. Together, these structures tell a powerful story. Humans are capable of creating things that are far greater than their own lifetime. They show that architecture is not only about solving practical problems, but also about expressing ideas, preserving culture, and connecting generations. In the future, advances in science and construction technology may allow humanity to create buildings that are even more durable than those of the ancient world. New materials such as shell-healing concrete, advanced nanotechnology, intelligent monitoring systems, and sustainable design could make it possible for future structures to survive for thousands of years. However, creating a truly timeless building will require more than advanced technology. A structure must also have meaning and value for future generations. The greatest buildings are not remembered only because they are strong. They are remembered because they represent something important about the people who created them. Future architects may one day design buildings that can adapt to environmental changes, repair themselves, and continue serving humanity for centuries. These structures can become the future great monument, symbol of innovation, sustainability, and human achievement. Such buildings will become more than physical spaces. They would become messages from one generation to another, carrying knowledge, creativity, and hope across thousands of years. They would represent the connection between the past, present, and future of human civilization. The buildings that survived for thousands of years reminded us that time cannot completely erase human achievement. Although civilization rise and fall, the idea and creation left behind can continue in spite of people long after their creator are gone. Ultimately, the greatest legacy of humanity is not only what we discover or invent, but what we created preserve for the future. When intelligence combined with creativity, patience, and determination, humans can achieve something that approaches immortality. The timeless structure of the past and the potential wonder of the future share the same message. Humanity has the power to build beyond its own era and create monuments that stand an eternal symbol of imagination, knowledge, and the endless pursuit of greatness.